Hello, everyone. Welcome to the fourth part of Module 3, Temperature and Heat. I wanted to, before we start on this, just give you a little bit of a heads up. This particular module will be a little bit different in how it is presented because some of this material I had recorded earlier for a previous class, so it will be broken up into three videos instead of just one. You may have also noticed on section 3.3 that was also recorded for a previous class. So we didn't go through some of this introductory information on that one either. I will go through the introductory information here. So this is a list of the things you will need to do by the end of this module. Know how the terms endothermic and exothermic describe processes where energy is transferred as heat. Know the definition of temperature. Convert between any of the following temperature scales: Celsius, Fahrenheit, Kelvin. Memorize the heat equation. Perform calculations using the heat equation. And measure temperature changes and use these measurements to perform calculations using the heat equation. So in the video we're watching right now, we will just look at this second one, temperature. And then in the following video, you'll look at the rest of this material. And then there's a third video which has an answer key to a problem at the end of that second video. So again, a little bit of a different format than some of what we saw in Module 2. But all of the information is presented here. We'll again start with temperature and then go to the next video to get this first point along with the others. Okay, so I'm going to go ahead and skip through this because this will be on the second video. And some of this, again, is review from previously. Okay, so let's talk a little bit about temperature. Temperature is a measure of, a relative measure of thermal energy. Temperature is not the same as heat. Heat, as we'll see later in this submodule, is a measure of energy. Temperature is not a measure of energy. However, temperature is related to heat, and we often cannot measure heat without also knowing the temperature. One way to think about temperature is that temperature is a measure of which direction heat is going to flow in. Heat flows from things that are at a higher temperature to things that are at a lower temperature. So you could even think of it almost like an elevation. So high temperatures are high elevation, low temperatures are like a low elevation, and then heat would flow like water flows from high elevation to low elevation. Heat would flow from high temperature to low temperature. So that's the idea of what temperature is. Not the same as heat, but we can measure temperature, whereas heat is not something we can measure directly, as we will see. So we want to look at a few different temperature scales. So we have the Celsius scale and the Fahrenheit scale. These are the two we might be the most familiar with, and maybe the Fahrenheit is the one where between these two that we're the most familiar with. One thing you'll notice between these scales is that they start at a different point and they change at a different rate. So the freezing point of water is 0 in Celsius and 32 in Fahrenheit, so they start out in different places. And then if you add 100 to this, you get to the boiling point for Celsius, whereas Fahrenheit you have to add quite a bit more than that to get to its boiling point. So they start in different places and change at different rates. So that's going to make the conversion between them a little bit more challenging. We also have the Kelvin scale. Now the Kelvin scale is related to the Celsius scale. So if we look at this difference of 100 degrees, we see the same difference for Kelvin. So Kelvin starts at a different location than Celsius, but it does change at the same rate. So converting between Kelvin and Celsius, we simply add 273.15 to a Celsius temperature to end up with our Kelvin temperature. And we can see that relationship there. Again, for these two, the relationship is a little bit trickier because they both start in a different place and change at a different rate. So in order to keep track of that, we do first the subtraction, so Fahrenheit minus 32, to get the same kind of starting place, and then we do this division to account for the different changes the different rate of change between Fahrenheit and Celsius. Okay, and again, based on those differences. I guess one last thing I'll say on this before we end, and the rest of this PowerPoint you'll go through in the later video, is that the Kelvin scale is what we call an absolute scale, meaning that when we have 0 Kelvin, we cannot be any colder than that. And we will discuss in a later chapter why that is. So why is 0 Kelvin the lowest possible temperature? So that is the end for this first kind of short video. One other thing I should mention, the PowerPoint might be a little bit different for this one than the one that you can download. We'll be covering the same information, but I believe I made a few changes to some of the slides with maybe some different examples, but you will be covering the same information. So go ahead and feel free to move on to that second video to continue, and I will see you there.